Welcome back to part 2 of section 4.5. We're still graphing sine and cosine. So take a note for the sine of x. We're going from 0, max, 0, min, 0 for our key points. And for cosine of x, we're going from max to 0, min, 0, back to the max. That's our key points. That's how they work. As we talked about, amplitude is that number in front. When we talk about amplitude, we talk about the absolute value. Amplitude is always going to be a positive number. Now, amplitude, that's going to cause a stretch and a shrink. And we'll see that when the A is a number, the absolute value is between 0 and 1, we're going to have a compression. It's going to shrink vertically. When the absolute value is greater than 1, it's going to have a vertical stretch. Our rules with reflection, if our leading coefficient is negative, there we have that reflection along the x-axis, and we'll talk what happens when we have a negative inside later on. That would be a y-axis reflection. So now, looking at problem number 3, we're going to graph them all on the same axes. You can see for A, our amplitude is 1/2. For B, our amplitude is 3. And for C, our amplitude is still 3. But there is an x-axis reflection. So we'll talk about that more. Now, I'm just going to do 2 periods. So I cut it my key points. Here's my pi over 2, my pi, 3 pi over 2, my 2 pi. I'm going to go backwards and do the same thing for my other period. Negative 2 pi. So now I need to make room, so my amplitude is 3. 1, 2, 3. So now for the first one, it's cosine. Remember, cosine, we go max, 0, min, 0, back to max. Now for A, our maximum is 1/2. So we're at 1/2, 0, negative 1/2, 0, and 2 pi. So there is one period. And if we go backwards, same thing, 0, minimum, 0, maximum. You want to make sure it looks like a nice smooth curve like that. Now, if we look at B, 3 cosine of x. So now we do the same thing, max, but our maximum's at 3, 0, negative 3, 0, and then positive 3. Here's one period of 3 cosine of x. You can see how stretched out that is. So if we go backwards, we're at 0, minimum, 0, maximum again. And you can see it, nice smooth curve, nice smooth wave that was created. And now, for the reflection. Now, what we're doing is we're multiplying by negative 1. So we're not going to start at our max. We're actually going to go min, 0, max, 0, and then back to the minimum, because we're multiplying by negative 1. So for the last one, for C, we're starting at negative 3, then the 0, then the positive 3, 0, and then negative 3. There's one period of that. And if we go backwards, we're back to 0, then back to the max, 0, and then minimum. And you can see how that's a reflection of the blue graph. If you flip all those points, you would have the blue graph. There's that reflection. Let's go to the next page, and let's talk about the period of these sine and cosine graphs. The period is how long it takes to do one complete cycle, one complete from 0 to 2 pi. Now, that's great when our period is x. But we're going to be looking when we have the sine of bx and the cosine of bx, when we have a value in front of x. To find the period, what you do is you do 2 pi divided by b. That will tell you what the period is. That will tell you what the period is. So now, when we do that, for number 4, the period, b is 2. So the period is 2 pi divided by b. So it's going to be 2 pi divided by 2. The period for this is pi. That means to complete one full cycle, we only need pi as opposed to 2 pi. That's our period. So now our interval, our starting and stop for one period. What you can do is set 2x equal to 0 and 2x equal to 2 pi. That'll help us find our starting and stop points for one period. Divide both sides by 2, so x equals 0 and x equals pi. That's our interval. So our interval goes from 0 to pi. And you can see that's the length of one period. We also have what's called the increment. And that increment is for our key points. So to find the increment for sine and cosine, it's your period divided by 4. So in this case, it's pi divided by 4. So our key points are going to be pi over 4 apart from each other. Now for number 5, y equals the cosine of pi over 2x. So b is pi over 2. So the period is going to be 2 pi divided by pi over 2. We don't divide fractions, we multiply by the reciprocal. So it's 2 pi times the reciprocal, which is 2 over pi. The pi's cancel, so our period is actually just a 4. So the period is 4. Now I'll find my increment next. The increment is going to be the period divided by 4. So the period is 4 divided by 4, so the increment is 1. And now our interval. Same thing we did. Now what it's going to be is pi over 2x equals 0. Pi over 2x equals 2 pi. Multiply both sides by the reciprocal, 2 over pi. X equals 0. Multiply both sides by 2 over pi. And just like we saw before, x equals 4. So our interval for one period, we would start at 0 and stop that period at 4. That's one interval. So what that means and how that affects us, we're looking at sine here. So remember, sine goes 0, max, 0, min, 0. That's how the key points work for sine. So if we look at problem 6a. So for a, our period, it's 2 pi divided by 1, which is 2 pi. That means our increment is going to be 2 pi divided by 4, which is our pi over 2. And our interval, that means we're starting, so do x equals 0, x equals 2 pi. That means our interval for one period, we're going from 0 to 2 pi. So sketching this, here's my pi over 2, pi 3 pi over 2, and here's my 2 pi. So our amplitude is 1. So we go from 0 to max to 0 to min, back to 0. So it goes up, turns back down, and there's 1 period. Now for part B. For part B, our period is 2 pi divided by 2, which is pi, which means our interval, our increment, that's going to be pi divided by 4. And our interval, 2x equals 0 to 2x equals 2 pi. So x equals 0 and x equals pi. That's how long it takes to do 1 period. So now our increment. We're not going pi over 2, we're going pi over 4. Now, 2 pi over 4 is the same as pi over 2. Then we have 3 pi over 4, and then 4 pi over 4 is pi again. So now what this graph is going to look like, we still do 0, max, 0, min. We go 0, then we do max, 0, min, and then back to 0. Do you see that horizontal compression? We squeezed everything in. There's that horizontal compression. And we can deal with that by following the rules we just talked about, by finding the period, interval, and increment. Let's go to the next one, problem number 7. The sine of x over 2. We're still talking sine, so we're still following that 0, max, 0, min, 0 pattern. So now, the period. The period is going to be 2 pi divided by 1/2. So that's going to be 2 pi times the reciprocal of 1/2, which is 2, so it's going to be 4 pi. This actually be stretched out a little bit. So now our increment, it's the period, 4 pi divided by 4, which is pi. And our interval, x over 2 equals 0, x over 2 equals 2 pi. So we multiply both sides by 2, we get x equals 0. Multiply both sides by 2, we get x equals 4 pi. Our amplitude is 1. So now I'm at pi, because my increment, that tells me where to start. So 0, then we go to pi, then we add another pi, we're at 2 pi. Another pi, we're at 3 pi. Add another pi, we're at 4 pi. Now, my amplitude is 1. So I still do the same thing, 0. Now my maximum's at pi. My minimum's at 2 pi. I'm sorry, 0 is at 2 pi. My minimum's at 3 pi, and then back to 0 again. So what this looks like is this. It took us longer to complete one full cycle. There's that horizontal stretch. And all of that was done for us by setting up finding the period, increment, and interval. Let the math do the work for you. Number 8. This is a cosine graph. So for cosine of theta or cosine of x, it goes max, 0, min, 0, max. That's the pattern it follows. And that does that at the increments that we find. Now, for the period, well, the amplitude, first off, is 1. Now the period, that's going to be 2 pi divided by 2 pi. So our period is 1 as well. Looks weird, but it's okay. We'll deal with this. Our increment, that's our period divided by 4. So our increment is 1/4. And now our interval. That's going to be set 2 pi x equal to 0 and 2 pi x equal to 2 pi. Divide both sides by 2 pi. X equals 0. Divide both sides by 2 pi. X equals 1. So I know it seems weird, but this time our x-axis doesn't have pi's in it. And that's okay. Just listen to what the increment tells you. Sorry, interval goes from 0 to 1. That's the length of one period. So now, instead of doing like a pi over 2 or a pi over 4, we're just going to do 1/4. 2/4 is the same as 1/2, 3/4, and then 4/4, which is 1. So since it's cosine, we start at the maximum, 0, minimum, 0, and then back to the maximum. Here's 1 period of the cosine of 2 pi x. Now it would keep going, but this is just 1 period. The keys here to take away is how to find the amplitude, period, increment, and interval. And remember the patterns for sine and cosine. I'll be back again and we'll talk about more transformations of these functions.